So our topic for today is law of sins. So general content. So we learn to specify the triangles. In chapter 4, we will start the chapter by learning to solve unique to triangles, non-right triangles. So please note the angles are capital letters. The size of opposite is the same letter in lowercase. So what is already know? So the interior angles totals 180. So we can use the Pythagorean theorem. Why not? For letter area 1/2 BH. So playing with the triangle, if the think of each as being opposite by both A and B, then A equals each over B and sin B over each A. So let's solve both for each. So H equals B sin A and H A sin B. So that means B sin A since B adding of the so so let's drop the attitude one. So if will be drop of attitude of side E could come up with sin B over B equals sin C over 6C. Put it all together as the law of sin. So sin A over A equals sin B over B equals sin C over C. So A sin A equals B over sin B so equals C over sin C. You can also use it upside down. So what good is it? So the law of sins can be used to solve the following types of oblique triangles. So triangles with the two no angles and one slide AAS or ASA. So triangle with two no sides and one angles opposite one of the side is A. With these types of triangles you will almost always have enough information data to fill out one of the fractions. So sin A over A equals sin B over B equals sin C over C. So general process. Except for the ASA triangles, you will always have enough information for one full fractions and half of another. Start with data find a 40 phase of data. So once you two angles you also you subtract from the 180 to find the theta to avoid a rounding error. Use another data extend for compute data whenever possible. So examples number 1 EES. So let A 45 degree B equals 50 degree A equals 30. So and given both ways for the scenes A and part of the scene B over B. So we start here. So 45 scene 45 equals 30 equals scene 50 over B. So cross multiplies and divide to get. So B sin 45 equals sin 30 sin P. So B equals 30 sin 50 over sin 45. So once I have two angles, I can find the missing angles by subtracting from 180. C equals 80 equals negative 45, negative 50 equals 85. So sin A over A equals sin C over C. So sin 45 over 30 equals sin 85 over C. So cross multiply and divide to get C sin 45 equals 30 sin 85. C 30 sin 85 over sin 45 using a calculator. C equals 45.3. So using calculate so using KB equals 32.5. So we repeat the process to find side C. Remember to avoid rounding values when compute. We then denote at the side and all three angles. So examples 2 as so let A 35, B 10, and C equals 45. So since we start of the fractions, we will start finding c. So c equals 180 minus 35 minus 10 equals 135. Since the angles were stack this, since round value, we use sin c over c as our starting functions. So sin c over c equals sin a, and sin c over c equals sin b over b. So since 135 over 45 equals sin 35 equals a, so, so cross multiply and divide. So a sin 135 equals c equals 45 sin 35 of a 45 sin 35 over sin 135. So using your calculator, so answer is e equals 36.5. So sin, so answer of b equals 11.1. So examples of number 3 is SA. So late a equals 40, b equal 10, and e 7. So we have enough information to use sin a over a as our starting fractions and can go to work on b. So sin a over a equals sin b over b. So sin 40 equals 7 equals sin b over 10. So we cross multiply and divide to get sin b equals 10 sin 40 over 7. So we we have to get rid of the same functions to find the answers for angle B. So to do this, we apply the inverse equation. So sin over 1 negative 1 sin B equals sin over negative 1. So 10 sin 40 over 7. So B equals sin over 1 negative 1. So 10 sin 40 over 7. So with a calculator, so B equals 66.7 degree. So we need something to start the fraction sin over c. So since it is critical that the angles to 180, we will find c by subtracting from 180. So c 180 minus 40 equals 66.7 equals 73.3. Now we use our starting fraction sin a over a with the sin c over c. So sin 40 over 7 equals sin 73.3 equal over 3. So cross multiply and divide the finish. So c sin 40 equals sin 7 sin 73.3. So equals 7 sin 73.3 over sin 40 equals 10. The answer is 10.4. So append in the angle side. So let's consider the case where we have an angles and adjacent sides and opposite side. For example, I have angles as side B and side A. So sometimes A is too short to reach. You attempt to work these problems like example number 3. You can calculate will give you an error message and catch the error. So sometimes A is just right. So it is reaches with a right angle. So you work this problem like example number 3 and will never know there might be a problem. So sometimes A is long, so it only really reaches one way. This problem also work like example number 3. You never know this might have been difficult. So sometimes A is just a right light that it is can form two different triangles. Following example 3, solving the outer triangle, you have to be on the lookout to catch the second triangle. So if you don't get an error and E is B, then there will be either a right angles or two triangles. So contacting triangles. So solving like 3 will be give you the purple outer triangle. So since the two red lines A are equals the two base angles B are also equal. So since B and B form a straight line, B equals 180, so minus B, so use B to compute C, abstract A and B from 180 to find C. So another perspective on starting the another triangle. So if the two sides are equal, the two angles are equal, since complementary angles to the 180, B equals 180 minus B. So since A and in B and A are given, once you know B, you can finish the triangles on the left. So an example open in the angle side. So let A 40, B 10, and A equals 9 angle side. So we will process like example number 3. So we have enough information for A and start for B. So sin A over A equals sin B over B. So sin 40 over 9 equals sin B over 10. So cross multiply and divide to get. So 9 sin B equals 10 sin 40. Sin B equals 10 sin 40 over 9. So to get the angle B, you must unlock sin using the inverse. So sin over n, sin B equals sin over negative 1. So 10 sin 40 over 9. So B equals sin over negative 1. So sin 10 sin 40 over 9. So answer is 45.6. So once you know to angles to find the third by subtracting from 180, say 180 minus 40 minus 45 minus 45.6 equals 94.4. So we'll ready to look the sides here. Remember to use the starter fractions A. So cross multiply and divide, then use the calculator. So C for since 40 equals 9, since 94.4, so C equals 9 sin 94.4 over sin 40 equals, the answer is 14.0. So find the second angle, start from the finding B. So equals 180 minus B. So now solve the triangle. So starting the triangle C, so 180 negative 40 minus 134.4. So C equals 5.6. So finish the finding sides using the starter fractions A. So sin A over A equals sin C over C. So sin 40 over 9 equals sin 5.6 over 6. C sin 40 equals 9 sin 5.6. So C equals 9 sin 5.6 over sin 40. The answer is 1.4. So a new way to find area. We will know that A equals 1 half BX, and the few slide back we found his H equals B, since A and H is a sin B. So it's look like a base in C. To make the little substitute, give me area E 1 over 2 BC sin E equals 1 over 2 EC sin B. So if the draft attitude in the different directions, we can add area 1 equal 1 over 2 ABC sin C. So it always the side that include angles. So an area examples of find the area of a triangle inside A over A side B. So B12 and angle C40. So choose the appreciated formula. So in the case we will choose area 1 over EB sin C. So fill it the blanks. Area 1 of 10, 12 sin. So 1 plug into the calculator area 38 point square units. That's all. Thank you.